right? Then let's try the programming. Okay, so then as always, open new script. Okay, open new script. Okay, as always, CLC and clear. Right. So then the first step is specify true values or the specification. Okay, and then the second step must be sampling. The third step must be just report. Okay. Okay. So then we need to specify what? How many samples? Say for now 3. Okay. And how many simulation size? Again, it's 10,000. Say simulation size. This is sample size. Okay. So then, and then mu is what? Okay, so then we need to pick an arbitrary distribution. Okay, and then my choice is uniform distribution. Okay, uniform distribution over between 0 and 1. Okay, so then its mean is 0.5. Uniform distribution is definitely it's not normal distribution. Okay, then mu is 0.5, and its variance sigma square is 1 over 12. Okay, 1 over 12. Okay, so this is mean and variance. Okay, okay, okay. And then the second step is sampling. We are going to sample the sample averages, right? So then let's make a room to save the normalized sample average. Okay, so then let's say x, okay, x bar m equals zeros. Okay, zeros n comma 1. Okay, this is the storage of normalized sample average. Okay, again, let's go back to this algorithm. Here we are going to repeat these steps 1 through 3. Okay, right? So that we are going to repeat these steps 1, 2, and 3, right? So then whenever you would like to repeat something very similar jobs, then you will have to use for looping. It's called for, and let's say here ITR 1 colon n, not semicolon. Okay, so then ITR is just index. It starts from 1 and increases by 1, 1, 2, 3, like this. Okay, after typing this, I'm gonna explain how it works. Okay, so then the first step is what? The first step is we need to draw capital T samples from standard normal. That's the uniform distribution. X is rent, and capital T comma 1. Okay, so we have capital T samples. Okay, the next step is what? The next step is compute sample average. Okay, x bar is sample average, which is mean or mean C, whatever, it doesn't matter. This is sample average. the next step is what? The next step is compute is normalization. Okay, x bar minus mu times square root times divided by sigma. Okay, then here x bar minus mu, right, times square root of capital T divided by sigma. Sigma is square root of what? Sigma square. And then we are going to save it here. ITR, comma 1. Okay. Then we are almost done. Okay. Oh, let me save it. The CLT. Okay. Here again, ITR begins at 1. Okay. ITR is 1. Okay. The next line. Capital T samples are drawn from this uniform distribution, and then sample average is computed and assigned to x bar. And then here we compute x bar minus mu times sigma square root of capital T divided by square root of sigma square, right? And then it's saved where? ITR is 1, right? ITR is 1, 1 comma 1. Okay, so previously the 1 comma 1 of x bar m was 0 because this is just the vector of zeros, right? And then the 0 is replaced by this value, right? So then 1 comma 1 of x bar m is now replaced by this value. Okay, then you see end, and then end is met, then it goes back to the first line. Now ITR increases by 1. Now ITR equals 1. No. Now ITR equals 2. And then another capital T random samples are drawn. Then this is a sample average, and then this is its normalization. Again, this is ITR is now 2. 2 comma 1 is replaced by this value. Now we have the end here, and it goes back here. Now ITR is what? Now ITR is 3. Here another capital T independent random samples are drawn. Then this is its sample average, is normalization, and this is saved where? It's saved the third entry of x bar m, 3 comma 1. Now we have end. Now ITR becomes what? 4, and it's repeated until when? Until ITR is between 1 and capital N, right? And at the last iteration, ITR equals to N, right? When ITR equals capital N, then still we will have capital T random samples from the uniform distribution, and we compute sample average, and its normalization is saved here. X bar m, n comma 1, right? Now we have end. Now ITR equals n plus 1, but n plus 1 doesn't belong to here. So then this for looping is done. Then MATLAB moves to the next line. Okay. So here we would like to plot the histogram of x bar. Okay. Okay, let me run it. Yeah. So this is the histogram of x bar. Okay. Right. So then it doesn't look like normal distribution, right? So then what if this capital T is only 2. So this sample average of 2 random variables. Okay. Definitely this is not a normal distribution. What if this is 30? Yes, it looks more likely normal distribution. Okay. 100. Yes. So maybe this 10,000 is not many enough. 100,000. Yeah, this is very pretty, right? But still, what if this is 2? Yeah, this is almost triangle. With 3, looks better. 5, yeah, getting better as well. And then 10, yes, this it still looks like these tails are still quite heavy, but yeah, it looks much better. Yeah, what if this 30? Yes, much better. So, right? So you see that you can test the or you can see the how many samples or how many samples can look like the standard normal distribution by using this simulation test simulation study like this. Okay, so this is for looping. Okay, this is for looping. Whenever you try to repeat very similar jobs, then for loop is very popularly used. Okay.